Good morning, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the another video lecture series on inverse Z transform. See, Z transform is used for the analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very much useful in discrete time signals as well as system analysis. X of n and X of Z is called as forms the Fourier transform pair. This is the ROC of Z transform, that is S plane and Z plane. Z plane can be mentioned in the circle. S plane can be, that is nothing but in terms of Laplace transform. Z transform of X of n is denoted by X of Z. X of Z is equal to summation n is equal to minus infinite to plus infinite X of n into Z power minus n. When Z is a complex variable, Z is equal to R into e power j omega. Inverse Z transform can be defined as X of n is equal to 1 by 2 pi j integral over X of e into v of n minus 1 into dv. That can be classified into two types: unilateral or one-sided is the transform, bilateral or two-sided is the transform. X of z is equal to summation n is equal to 0 to infinite X of n into z power minus n is the one-sided is the transform. X of z is equal to summation n is equal to minus infinite to plus infinite X of n into z power minus n. Inverse z transform can be obtained by using partial fraction method, power series expansion or long division method. ROC region of convergence is the region where Z transform converges. Z transform is an infinite power series. It's not convergent of all the values of Z. Significance are ROC gives an idea about value of Z for which Z transform can be calculated. ROC can be used to determine causality and stability of the system. This is the basic discrete time signals. U of n is the value of amplitude of 1 for all the positive values of independent variables. 1 for n greater than or equal to 0, 0 for n less than 0. Del of n unit impulse function can be defined as del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. Unit ramp signal can be defined as R of n is equal to n for n greater than or equal to 0, 0 for n less than 0. The graphical representation of discrete time signal is also given. Next, this is the ROC of Z transform. When X of Z is equal to Z divided by Z minus A, when modulus of Z should be greater than A. That is, shaded part is, it can be represented as 1. The outside of the circle can be the shaded part. It can be represented as 1. The minus a2 plus a can be the shaded part. X of z is equal to z divided by z minus a when modulus of z should be less than modulus of a, means the inside the circle will be the shaded part. Minus a2 plus a will be the shaded part of ROC of z transform. Next one, inverse Z transform by using partial fraction method. These are the steps to follow. Convert X of Z to positive powers of Z. Bring X of Z to X of Z by Z. Apply partial fraction method. Multiply with Z. Take inverse Z transform based on ROC. These are the find the inverse Z transform of X of Z is equal to Z divided by Z minus 0.5 minus Z divided by Z plus 2. A power n into E of n gives Z divided by Z minus A, which is equal to 1 divided by 1 minus A Z inverse. Minus A power n into E of minus n minus 1 is equal to Z divided by Z minus A, which is equal to 1 divided by 1 minus A Z inverse. Therefore, 0.5 power n into E of n plus minus 2 power n into E of minus n minus 1 gives, which is equal to Z divided by Z minus 0.5 minus Z divided by Z plus 2. 0.5 less than modulus of Z less than 2. Next, we can see the problems. Find the inverse Z transform of Z plus 4 divided by Z square minus 4Z plus 3. Now we can multiply and divide by Z. Then bring X of Z divided by Z. We can apply the partial fraction method. A value gets 4 by 3. B value minus 5 by 2. C value 7 by 6. Now X of Z by Z. Now we can multiply with Z. We can apply the inverse Z transform based on ROC. We can get the X of n as 4 by 3 into del of n minus 5 by 2 into E of n plus 7 by 6 into 3 power n into E of n. Next one, another problem. Find the inverse Z transform of 8Z square divided by 2Z minus 1, 4Z minus 1. Therefore, we can get it as your f of z divided by z. Therefore, z divided by z minus 1 by 2, z minus 1 by 2, 1 by 4. Now we can get the value as a value as 2 divided by z minus 1 by 2 minus 1 divided by z minus 1 by 4. Now we can multiply with z and take inverse z transform based on ROC. We can get it as your where f of n is equal to 2 into 1 by 2 power n into u of n minus 1 power n into 1 by 4 power n into u of n. Next one, partial fraction method again. Find the inverse z transform of x of z is equal to z plus 1 divided by 3z square minus 4z plus 1. Now we can x of z by z multiple and divide by z. Therefore, a by z plus b by z plus 1, c by 3z minus 1. Therefore, we can substitute, we can apply partial fraction method. We can get the values as a is equal to 1, b is equal to 1, c is equal to minus 6. Now we can multiply with z. Therefore, x of z is equal to z by z plus z divided by z minus 1 minus 6z divided by 3z minus 1. We can apply the inverse z transform based on ROC. We can get it as x of n is equal to del of n plus u of n minus 2 into 1 by 3 power n into u of n. Next one, inverse z transform using power series expansion method. X of z is equal to, we can substitute the values from minus 2 to plus 2. X of n is equal to x of minus 2, x of minus 1, x of 0, 1, 2. X of n can be obtained by collecting the coefficients of z in x of z expansion. When the ROC is modulus of z should be greater than modulus of a causal system, then expand x of z such that the powers of z are negative. When the ROC is modulus of z should be less than modulus of a non-causal system, then expand x of z such that the powers of z are positive. Now we can see the problems. X of z is equal to 1 divided by 1 minus a z inverse. 1 numerator term outside 1 divided by a z inverse 1. Now we can substitute the values. 1 gets cancelled minus a z inverse. Then 1 into a z power minus 1 which is equal to a z power minus 1 minus multiplied with a into z inverse minus a power 2 into z power minus 2. Now we can get cancelled. Finally, we can get the value as x of z is equal to 1 plus a z inverse plus a square into z power minus 2 plus a power 3 into z power minus 3. Therefore, x of n is equal to 1, a square, a power cube. Now, inverse z transform is the reverse of the numerator and denominator term. Minus a z inverse plus 1 inside 1. Therefore, we can get the answer as x of z is equal to minus of plus up to a power minus 3 into z power 3 minus a power minus 2 into z power 2 minus a inverse of z. Therefore, x of n is equal to minus of a power minus 3 minus of a power minus 2 minus of a power minus 1. Now we can see the another problem. X of z is equal to 1 plus 2 z inverse divided by 1 minus 2 z inverse plus z power minus 2. Now we can get the, by applying causal system, numerator term inside 1 into 1 we can get 1 minus 2 z inverse plus z power minus 2. 1 gets cancelled. Therefore 2 plus 2 4 z power minus 1 minus of z power minus 2. Now we can apply 4 z inverse. Now 4 z inverse gets cancelled. Now multiplied with other term we can get it as your 7 z power minus 2 minus 4 z power minus 3. Now we can apply 7 z power minus 2. 7 gets cancelled. We can get the value as finally x of z is equal to 1 plus 4 z inverse plus 7 into z power minus 2 plus 10 into z power minus 3 plus up to etc. X of n is equal to 1, 4, 7, 10. Now we can apply the non-causal system method. Z power minus 2 minus of 2 z inverse plus 1, 2 z inverse plus 1. Now we can multiply with your numerator term and denominator term. We can get it as your x of z is equal to 11 z power 4 plus 8 z cube plus 5 z square plus 2z. Now x of n is equal to plus up to etc. 11, 8, 5, 2, there is no constant value. We can put it as your 0. Now another method, z square minus 1.5 z plus 0.5. There we get 2 z square plus z. Therefore we can get z square into 2 z square minus 3z plus 1. 2z square gets cancelled. Therefore 3z plus z, 4z minus 1. Therefore again multiplied with 4z inverse, we can get 4z minus 6 plus 2z inverse. 4z gets cancelled. 5 minus 2z inverse. Again multiplied with 5 into z power minus 2 5 minus 7.5 is Z inverse plus 2.5. Therefore, f of Z is equal to 2 plus 4 is Z inverse plus 5 is Z power minus 2. F is equal to 2, 4, 5. Now we can see the applications of Z transform. It is used for analysis of discrete time systems. It is used for digital signals. It is used to solve difference equations with constant coefficients, to characterize the transfer function of a discrete time LTE system, to design a digital filter. Define Z transform. Z transform can be defined as x of Z is equal to summation n is equal to minus infinite to plus infinite x of n into Z power minus n. Inverse Z transform can be obtained by solving using partial fraction method and power series expansion method. When the ROC is modulus of Z should be greater than a causal system, then expand x of Z such that the powers of Z are negative. List the steps to compute partial fraction method. First, we can bring x of Z to positive powers of Z. Bring x of Z to x of Z divided by Z. We can apply the partial fraction method. To multiply with Z, take ROC, take inverse Z transform based on ROC. When the ROC is modulus of Z should be less than modulus of a non-causal system, then expand x of Z such that the powers of Z are positive. ROC of Z transform can be used to determine causality and stability of the system. Thank you.